we get started. Okay. Notice on Thursday, I think I'm going to remind you that if you come in Thursday, you're going to have to wait for partying all day tomorrow. So Thursday, you're taking chip, right? For test, what we do 4? Wow, almost done. Okay, so make sure you come up on Thursday for taking chip. Now, if you look at glaciers, we essentially have 2 primary types. I know you're going to stop. We have alpine, also known as mountain glaciers. They're also known as valley glaciers for sure. And we have continental glaciers, which are also known as ice sheet glaciers. Alpine, meaning like the Alps, the mountains of Central and Southern Europe. Alpine. Mountain or valley. Some of the first studies of glaciers and glacial processes and features were done in the late 1700s and throughout the 1800s in the Alps, in Central Europe, and in parts of Sweden, the Caledonian, I have to concentrate to say that word, Caledonian Mountains, through Scandinavia, between Norway and Sweden. So in science, it's pretty much of a whoever gets there first gets to name it kind of thing. So usually in science, you get a lot of Latin and Greek words. That's what all scientists speak. But when it came to studying these alpine glacial features, we had scientists from Austria, Switzerland, France, Italy, Germany, Spain, and then people up in Norway and Sweden, Swedes and the Norse. So when it comes to glaciers, you get a lot of languages. You get French words, German, Austrian words, you get Nordic words. So just be prepared for seeing some crazy looking words. Not my fault. We're all people out of Europe that name them. So alpine, mountain, valley glaciers. These tend to be small. They are narrow and usually confined to the valleys in between the mountain ranges. We still have alpine glaciers throughout parts of the Rocky Mountains, throughout parts definitely of the Alps in Europe, the Himalaya, the Andes of South America, mountains that have high elevation where they can maintain that snow cover. When glaciers start forming and building and getting bigger and bigger, as they get bigger and bigger, they'll flow down out of the mountain valleys and they'll expand downhill to the bottom of the mountain. And when they get to the bottom of the mountain, that's when several valley glaciers can blend or mix together. They'll hook up and join with each other and all merge into one big sheet of ice and snow. Now, when they continue to advance and flow down across the lower elevations of the continent, then it becomes a continental ice sheet. That's what we currently have on the continent of Antarctica at the South Pole, and what's currently on Greenland. That during the height of the last ice age, which began about 2.5 billion years ago, and then did quite abruptly about 10,000 years ago, we had almost 2/3 of the entire northern hemisphere covered in glacier. Where you're sitting now, you're looking under about 300 to 500 feet of compacted snow. You would have been a lot more uncomfortable then than you are now. It's a lot of weight. So continental ice sheet, very, very huge in area. They can reach great thicknesses, sometimes 3, 4, 5 miles thick. And they cover continental low-lying areas, lower elevations. Now, I've mentioned several times that there was an ice age that ended about 10,000 years ago, and that it impacted North America, including here in Ohio. How do we scientists know that? How would you know, say, if you remember your high school days, or your middle school days, how would you know? Yeah, filter for mine. Okay. So, some of you it's a little buzz, a lot ago, some others, man, do we have school then? How would you know when you came home from school that your little brother or sister, or worse, your mom, had been through your room? It was a mess. You would know. I didn't put that there. That wasn't there. Oh my gosh. Oh no, she didn't find the stuff in the baggie, did she? Oh no, gosh, right? You would know. Things wouldn't be where you left it. Things would be in the wrong place. Things would be turned over, broken, disheveled. I had a friend got a new roommate. They came home from work and the place was just, they thought it was just tossed. They thought they'd been robbed. So, no, just, I knew it was just living. Yeah, I'm not, you're moving out. Yeah. That is good. I don't know. Memories. So we can tell when ice has been through a region because it does things to the landscape. And then it melts. And then it's gone. Okay, how many times have you seen Christmas Vacation? The movie, right? You remember the National Lampoon Christmas Vacation, the Grinch Waltz, right? Yeah. He's up on the ladder, he's putting the stupid lights on the house, and he falls, and he tries to catch himself on the gutter, and the gutter breaks, and the big sheet, the big thing of ice goes flying out of the gutter through the neighbor's window and into the stereo, and they come home and they're trying to figure out what the heck broke the window, what the heck broke the stereo, why is everything all wet? Because where's what happened together then? It what? Melted. It melted. Okay. Took a while to figure out what the hell happened there. It's the same thing with glaciers. They go through an area, they totally ransack the place, and then they melt. And it leaves you wondering what happened here. Glaciers. Let's look at some erosional features. Of glaciers. I'm going to make a list. We got striations, grooves, polish. That's polish, not Polish. Let's see. We can also have U-shaped valleys. Hanging valleys. Cirques. Getting into some French here. Cirques. Horns. Arêtes. It's always better if you can roll the R. Wow, what else is good? There's a great polish. Ooh. Fjords. Scandinavian for you. Fjord. That's a good start. These features are all from the scraping and grinding that glaciers do. Right? Glaciers also contribute to a lot of frost action, freeze and thaw, where the meltwater gets into cracks and crevices and rocks and then refreezes, expands, and pops all the rocks to pieces. As the glacier moves across the land, it's going to pick up. Rocks, boulders, pebbles, sand, grit. And that material will get frozen in the bottom of the glacier, like ice sandpaper. And as the glacier moves, it's going to be dragging those rocks against the ground. And that grinding action can create striations, grooves, and polish. It can actually put deep scratches in the bedrock. If you have soft bedrock like limestone, like we have up at Lake Erie at Kelly's Island and many other places, if you have really soft bedrock, you can actually cut the bedrock into big decorative grooves like crown molding. Just by dragging those rocks, the frozen glacier along the ground. You know, those glaciers can be miles thick. That ice is heavy. So not only do you have those rocks frozen in the bottom, and they're under a tremendous amount of pressure from the weight of the ice pushing down on it, and it's moving. So it's literally just smushing that right underneath the glaciers, just right into the rock below. Cut it up. Okay. You know, like when you get in a fight at a bar, someone puts your face, you know, you're not too pretty anymore. Polish. You get very, very fine sediment frozen in the bottom of the glacier. And as that goes over the bedrock, you just buff it. Just grind it smooth, just like a baby's butt. You go to Central Park, where there are huge boulders that are exposed from the passing of the glaciers. The glaciers took everything off the top and just left those rocks there. And you feel it, they're just as smooth as silk. And it's from the glaciers grinding across the rock and buffing them smooth. They shine. The bowling ball got polished. Then you have U-shaped valleys and hanging valleys because glaciers are made of ice, and ice is made of snow, and the snow is made of water. And water wants to get downhill the fastest, most easiest way possible. And if there's a pre-made path that'll help it out, that pre-made path downhill is usually a valley made by a stream or river. Now, coming out of the mountains, most of our stream valleys are what we call V-shaped. Because that fast-flowing water is digging down into the rock and carving a notch, a sharp notch through the rocks as a V-shape. Well, when glaciers come along, there's a stream. That must be downhill. I'm going to go that way too. Problem is, glacier's a little bit bigger than the stream. So the glacier coming through that valley behind that stream would be like a dump truck going through that door after you did. That door is going to be a little bit bigger after the dump truck goes through it. And it's the same thing with the glacier. The glacier follows the stream valley. Because the glacier is so much bigger, it will just ream that whole valley out. And will recarve it. Now we get a big capital U-shape valley. It looks to be much bigger than the original stream. Glaciers have a job. They're trying to move all of that frozen snow and all of the sediment that's in it. They're trying to move all that stuff downhill. Like streams, glaciers also have tributaries. Smaller glaciers that occupy smaller valleys that help them out. That help bring sediment and snow from surrounding areas. In an alpine region, in a mountainous region, your valleys during the Ice Age will all be filled with glaciers. Some of those valleys are going to be bigger than others. The bigger valleys are going to have a lot of smaller valleys that come down to join it. Now, a smaller glacier is not going to be able to cut as big a valley, but it can cut a little one. And then when all the ice is melted, the streams come back, and then you get streams flowing through those valleys. But now you have these smaller valleys that are elevated. They represent little tributary glaciers that are coming downhill to join the big glacier. But now that all of that's melted, you have just streams and rivers. Of course, this will make a waterfall. Hopefully it won't be a green waterfall. And that's a hanging valley. It's hanging sometimes several hundred feet off the bottom of the main valley. Any questions? You have cirques, horns, and arrests. These you'll find up in the mountains. These are characteristic mostly of alpine or mountain glaciation. Cirque, that's French, means circle. Like circus from Three Rings, you know, everything's done in a circle. Circular, right? Cirque. From Latin, meaning circle. A cirque is a round, kind of bowl-shaped depression on the side of the mountain. Being that it's a low spot, it's going to collect snow. It collects more snow, and more snow, and more snow, and snow, snow, snow. As snow starts to build up, you get a lot of freeze and thaw action, and that breaks the rocks apart and makes the depression bigger. Well, when the depression is bigger, it holds more snow, so more snow piles up, and then it just becomes a self-perpetuating process. Cirques are going to be the birthplaces, the starting points of alpine glaciers. Eventually, the snow and ice in those depressions will build up so much that they'll start to spill out and flow down the valley. During an ice age, you can have cirques and glaciers develop on multiple sides of the mountaintop. As those cirques continue to get bigger and bigger as the glaciers grow, that's like a parasite. Then the formation of those cirques, eating away at the rock by the snow and ice, will wear away at the sides of the mountain. Like you can use a knife to wear away and whittle at a stick. And it can actually tear the sides of the mountain down and sharpen it into a sharp point. And then you have a mountain. You go from mountain to horn. You've got a cirque here, and a cirque here, and a cirque develop on the other side. And it's straight side of the mountain, whittled it like a pencil, and now you have this really steep-sided, real pencil point looking mountain. That's called a horn. Most famous horn is the Matterhorn, the Swiss Alps. A lot of people have died trying to climb that sucker, more so than on Everest even. It is a very severe challenge. And I think that's why people try to climb it. Challenge. Do it. I did it! I broke both legs and my pelvis and my back and 3 places, but I climbed the Matterhorn. That kind of stuff. Now, that's French. And it refers to the backbone of a fish. Yeah. Now you have your fish, right? And, yeah, this is, of course, after you've eaten the fish, right? You know, the backbone is just that really, the spine of the fish. That's the nutette. Well, up in the mountains, you get these huge valley glaciers. And you get a valley glacier forming on either side of a mountain range. As they get bigger and bigger, and as they move, they will scrape at and carry away the sides of the mountain. So again, you start with this, but then if you've had a glacier, a valley glacier form on both sides, then as those glaciers grow and get bigger, and as they move past, they'll scrape the heck out of that thing. And you'll be left with just this little thin, jagged ridge of mountain because they got scraped by on both sides. Those glaciers are nice, clawed on both sides, and left just this thin, narrow, knife-like ridge of where those mountains used to be. Sometimes at the time, this could be easily, this could be 1,000 feet or more, almost straight vertical. And you have only maybe a foot or two wide at the top. And yes, people will climb that thing so they can walk along the top. Yeah, I'm not one of them. I'll sit on the beach at sea level and watch it on the internet. Okay. I'm not going to be up there doing that. I'll be in the helicopter looking down. Oh yeah, hi, actually, yeah, looks great. Yeah, no, I'm not going to be up there. That's in the red. And then you have the fjord. Fjords are huge U-shaped valleys that form when you have mountains near a coastline, which they do in Scandinavia. Mountains go all the way almost all the way to the seashore. And that's where the glaciers want to go. They want to get to the ocean so they can melt their snow and sediment. Now, in a fjord, once that ice melts, then you have these huge, steep-sided, narrow, deep valleys by the coast. And of course, the ocean is going to flow in there once the ice is melted. The ocean will flow back in and flood it, and now you have an inlet. That's a fjord. And these are hugely strategic because that's like the only way in and the only way out. So if you have enemy ships and you're coming in here to try to sneak in here to attack, it's a lot easier to be up here, 800 feet up or more, shooting arrows, throwing rocks, dumping, I don't know, boiling oil, I don't know, arrow. Boiling oil and things like that. Some of those long bows. Okay, so it's a spear. It's a spear shot from above. Because it's a lot easier, right, to be at the top of the hill doing this, taking people off a boat, right, than it is to be on the boat, like, and then doing this. Okay, who shot bow and arrow in here? Anybody? Basically, familiar with the basic concept, right? Seen with the movie they shoot the arrow up and then see who can stand there longer before they run. Yeah, grown-ups too, okay. So when you do this with the arrow and you let it go, the arrow's going to go up, and then it's going to do what? Come back down. Okay? You don't need to be shooting your own guy. So, thankful. You don't need that. It's not very helpful. So it's hugely strategic. There's a picture in your book. You don't remember the page number. It's in the Glacier chapter. You gotta look at it. It's creepy. It's a fjord in, I believe, Norway, and it's called Pulpit Rock. And if you look, you gotta look at that photograph in your book. You look very, very closely. You see a lot of little colored dots standing on top of those are people. People go there. And I know, if anyone here, I'm sure there are people in here that would be the kind of people that go to the edge, so you can sit down and hang your legs off the end. Are there people like that in here? I would be in the parking lot. Yeah, I can see it from here, it's fine. No, I don't need any closer. It's an 800 some odd foot drop to the water below. There's a big crack running behind it, which means that eventually it's going to what? Break and fall off. In my mind, I'd be thinking, okay, it's waiting for me to be there to break and fall off. So I'm going to stay over here. That's the way my brain works. I mean, it's been there for over 10,000 years. It's a little old time. This is yours. On Thursday, we'll take a quick look at some depositional features. What kinds of things get left behind in the ice now, piles of sediment. So look at that. We'll take a little bit of a closer look at how and why glaciers move.